So now we're going to look at the binomial probability distribution, and we're going to look to see how do we calculate the mean and the variance and the standard deviation for a binomial random variable. And you may have noticed by now that in all of these different distributions, in all of these different ways, types of random variables, we always want to be able to calculate the mean and the variance and the standard deviation, okay? Now, for a binomial random variable, it's actually really easy. To calculate the mean, you just multiply n times p. That's it. N is the number of trials, p is the probability of success, and when you multiply those two numbers together, you get the mean of the binomial random variable. It's just as easy to calculate the variance. It's n times p times q. So it's the number of trials times the probability of success times the probability of failure. And then the standard deviation, as usual, is the square root of the variance. So it's the square root of n times p times q, okay? So I'd like to calculate the mean and the variance and the standard deviation of our basketball example, where we said that a player is trying 4 free throws, 4 of them, okay? Their probability of success is 0.78. And so here we want to identify what is the mean, what is the standard deviation, and what is the variance, okay? Well, it's easy to calculate the mean because it's just n times p, which in this case is 4 times 0.78. And so we'll move over to a calculator real quick. All right, so we've got our numworks calculator here. We're going to do 4 times 0.78, which is 3.12. And so the mean of this binomial random variable is 3.12. Now, in order to get the standard deviation, first we need the variance. So variance is n times p times q. Now let me remind you, we're given n and we're given p, but q is 1 minus p, whatever 1 minus p is. So we know that q then is going to be 0.22. That's the probability of failure. And so here we're going to have 4 times 0.78 times 0.22, and that'll be our variance. So it'll be 4 times 0.78 times 0.22, and that gives us 0.6864. 0.6864. And of course, our standard deviation is going to be the square root of our variance, so that'll be the square root of 0.6864. Let's go to the calculator. Square root of 0.6864 is 0.828. We'll stop there. Well, we could go to the fourth one if we want to. We can do 0.8285 if we want to. So 0.8285, okay? And that's how we calculate the mean and the variance and the standard deviation of a binomial random variable. Now we're going to look at what we call cumulative probabilities. So now a cumulative binomial distribution probability just means more than one number, okay? So, previously we said, well, what's the probability of missing all the shots? Okay, what's the probability of 0? What's the probability of making one shot? Okay, but now what we're going to do is we're going to look at probabilities where the binomial random variable is less than a particular number, or less than or equal to, or greater than a number, or in between two numbers, okay? This is, when we do more than one of them combined together, we call that a cumulative probability, okay? So suppose we have a binomial situation where n is 12 and where p is 0.53, and we want to know the probability that x, the number of successes, is going to be less than or equal to 3. Well, 0 is less than or equal to 3. 1 is less than or equal to 3, 2 is less than or equal to 3, and 3 is less than or equal to 3. So what we need is we actually need the probability of all 4 of those numbers, and we're going to add them together. Add. So what we're going to do is we're going to go into we're going to go into Minitab, but you could also do it in Excel, and we're going to identify the probabilities of 0, 1, 2, and 3, given that n is 12 and p is 0.53. Okay, so one way we could do this is we can go to Calculate, and we can go to Probability Distributions. We can go to Probability Density Function. We're going to change Distribution to Binomial. We know that the number of trials, n, is 12, and we know that the event probability is 0.53. Okay, let's confirm that. Yep, sure enough, n is 12, p is 0.53. And so what we could do is this. We need the values for 0 and 1 and 2 and 3. And so what we could do is we could do a single value at a time. And we could find the probability of if x is 0 and then hit OK. And here it is. Okay. And then we could also then do the same thing again. Oops, wrong one. Calculate probability, there we go, density function, and we can change the value to 1 and hit OK. And so look, we have the probability when x is 1, and we have the probability when x is 0. The other possibility is we could go into C1 here, and we can key in 0, 1, 2, whoops, let's go up here, I messed that up, 2, and 3. And then what we could do is we can go to Calculate, Probability Distributions, Probability Density Function. We can change form of output into a column of values, and we could say that the values are in column C1. We still have n of 12, we still have a p of 0.53. Display a table of probability. We hit OK, and look, it gives us all 4 of the ones that we need. And these are the 4 that we need, and we want to add them together. So we want to add together this number. All right, so let's grab a calculator here. And we're going to do 0.0001162. 0.0001162 plus 0.0015723. 0.0015723 plus, this one is 0.009, well, let's say 0.0097516. 0.00975, what was it, 516. Okay, plus, and then this one is 0.0366548. 0.0366548. Press enter, and our cumulative probability is 0.048, and we'll round this up to a 1, so 0.0481. So this is going to be 0.0481. And remember, the way that we got that was we had to get 4 separate probabilities. We had to get the probability of 0, probability of 1, probability of 2, and probability of 3, add them all together, and that gave us 0.0481. So now let's say we want the probability of x greater than 9. Well, greater than 9 does not include 9, so we're not going to include 9, but all the numbers larger than 9 that go up to 12 are 10, 11, and 12. So we need 3 probabilities for this one. So if we go over to Minitab, we can, maybe in C2 here, we can put in 10, and 11, and 12. And then we can go to Calculate, Probability Distributions, Probability Density Function. And then in Values, we'll do a column of values, but this time we're going to use column C2. And look, we could even get it from all the way over here. Binomial, n is 12, p is 0.53. We'll hit OK. And look, here they are. We have 0.0254975, and then 2 more of them, okay? So we're going to go to our calculator, and we're going to add these up. So here we have 0.0254975, 0.0254975 plus, then we have 0.0052277, 0.005277 plus one more, 0.0004913. 0.0004913. When we press enter, we get 0.0312. So this is going to be 0.0312. And then this last one here says the probability that x is between 4 and 7. But notice how it says x is greater than or equal to 4. That means we're going to include 4. But less than 7. That means we're not going to include 7. We're only going to go up to 6. So this is asking for us to identify the probability of 4, 5, 6, and not 7. Okay, so 4, 5, and 6. Okay, so we can go back to Minitab, and in C3 we can put in 4 and 5 and 6. And then we can go to calculate, probability distributions, probability density function, and our values here. We can come over here actually and we can double click on C3. We have binomial, n is 12, p is 0.53. We hit OK. And look, it gives us the probability of 4, the probability of 5, and the probability of 6. So we'll go to a calculator and we'll put in, let's see, 0.093002. 0.093002. Why am I not rounding these numbers? Why am I putting the whole number in? Well, when you do an intermediate calculation, you're never supposed to round. In math, you're not supposed to ever round until you get to the final answer. Okay? So now we're going to put in 0.167799. 0.167799 plus, then this one is 0.220757. 0.220757. Enter, and we get 0.481, and we're going to make this a 6. 0.4816. So 0.4816. That's almost 0.5. That's almost half. So there's almost half of a probability that the number of successes are going to be either 4 or 5 or 6. Okay? And that's how we do cumulative binomial distribution probability.